Today's lesson will involve determining and understanding sample space. As we talked about in our first lesson, sample space is the set of all possible outcomes. And there's a couple of different ways you can use it. The two most common are a tree diagram and what's called set notation. They are helpful because knowing, excuse me, the sample space or the number of possible outcomes is sometimes not sufficient, and a tree diagram is a good way to help visualize what the possible outcomes are so that it's easier to determine a probability. Okay, so example one, and I know you're all pretty much familiar with tree diagrams, but let's just go through this. I have a die and a coin that are tossed, and I want to figure out the sample space. Okay, so what we're going to do, and there's different ways. I usually do a starting, and let me just give myself full space here. I usually start on the left here as my starting point. And what event you have go first is really up to you unless something indicates that one has to come before the other, which you'll see in some examples. Okay? So I'm going to toss the coin, which tells me I can get heads or tails. And again, some of you may have been taught that you can start the sample space up here and go down like that. That's fine. Our tree diagram, I should say. As long as you have everything listed, we're good. So after I do that, I have 6 outcomes for my die, which is 1, 2, 3, 4, 5, 6. And you want to just label things so that people can understand what it is. It's no problem using abbreviations as long as the abbreviations are clear. Okay? So there's my tree diagram. And now I want to figure out my probability. Well, the probability of getting a 6 and an H is 1 out of 12 because there's 12 possible outcomes. How do you do that? You count the branches, the last part. An odd number in tails, 3 out of 12. And then heads, 6 out of 12. Now remember, as we talked about, you do not have to simplify fractions. And if you see, for example, something like getting heads, you've got a 50-50 shot or 1/2, it's fine to use that also. Okay? Now, second example, boy, this orientation is very poor. I'll just talk about it. It's talking about presidents and what the paper was on in terms of specific time frame in their life. Okay, so we have 5 presidents that we're going to talk about, and then there are 4 aspects to their life. All right, so let's go to the next page. Let me get this open as much as possible. Okay, so my presidents, I start here. I've got 1, 2, 3, 4, and 5. I'm going to use initials, WC for Clinton, Bush, Reagan, Carter, and Nixon. Okay? And then off of that are my 4 branches. C, oh, it's not coming up. C for childhood, A for adulthood, P for presidency, and AP after presidency. You know, I'm going to do that. C, A, P, A, P. C, A, P, A, P. And you get the picture. C, A, P, A, P. And you would do that for each of these. All right, so now we want to answer some specific questions. You should see by the branches that there are 20 outcomes. And how many of them could be talking about a president's childhood? Well, 5 out of those 20. How many about Clinton? 4 out of those 20, or 1 out of 5. A president from the 90s. So you have to know that your president in the 90s are Clinton and Bush. So that's 8 out of 20. And childhood or adulthood before becoming president, 10 out of 20. Now, if you are asked to just determine the total number of outcomes, you don't need to put a tree diagram or, and let me actually go back for a moment, because what I wanted to do was show you, wrong way. I wanted to show you via this example how you would list this out with a, in set notation, okay? And you'll see why it's not desirable, especially depending upon how many outcomes you have, etc. So the way this would be done in set notation is I would, in braces, put each possibility, H1, H2, H3, etc., 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 so that I would list out each possibility as in this case, a set of ordered pairs, but it could be even more than a set of ordered pairs, especially if I have more than 2 particular things happening here, okay? So I just wanted to go back and mention that. All right, now, let's go to the next example. Oh, this board. Hopefully I'll get it to go. I don't know why it's doing this. Please bear with me for a moment. I don't know what's happening to my stuff. This is where you try to find something else to do while the teacher's trying to find his pages. All right, there we go. Okay, so as I was saying, if you're just asked for how many possible outcomes there are, you don't need to put a tree diagram or set out a set diagram. You can use what's called the counting principle, which means if I am choosing one of each for a particular event, I could just multiply the number of possibilities for each one. So let's talk about that. I have Jen has 3 pants, 4 shirts, and 2 belts. All right, and she's going to choose one of each. Well, we can tell from the counting principles that there's 24 outcomes. All right, that's nice. That helps us. But if I want to figure out probability, sometimes it's a lot easier to do the tree diagram. Okay, so what are her possibilities? Blue, pants, red, or black. Okay, now again, I'm spelling these out because there's commonality between blue and black. And whether I start with pants or shirts or belts don't matter, because it still gets me to the same end game. Then I can go to a pink shirt, a white, a striped, and a tan. And then off of that, I can go for black or brown. Now, I'm not going to do this all the way through. I'm just going to do this one branch, okay? Because I would just be duplicating this for red and black. And again, you'll see you have 1, 2, 3, 4, 5, 6, 7, 8 for blue, 8 for red, 8 for black. That's my 24 combinations. All right, so now let's go to the questions. What's the probability I'll have red pants? Well, again, you'll either see it's 8 out of 24 or 1/3. It's a question of how you visualize it. 8 out of 24 is the total 8 combinations have red pants out of 24. Or, since you only have 3 pant colors, 1 out of 3 have to be red. Probability I'm going to wear a belt is 1, because it says I have to choose a belt. Probability of a black shirt, 0. There is no black shirt. Now, this last question is where the tree diagram could be helpful. I have a tan shirt and a brown belt. Well, there are only 3 outcomes with tan shirt and a brown belt. Okay? Yeah, tan shirt and a brown belt. One with the blue pants, one with the red pants, one with the black pants. Now, we will be expanding upon this later on in this unit. But when you have the word and in probability, it means to multiply. So the probability that I get a tan shirt is 1 out of 4, because there's 4 shirts, 1 is tan. The probability that I get a brown belt is 1 out of 2. And when I multiply those, I get 1 out of 8, which is the same as 3 out of 24. So that's another way which we will expand upon later on how to do that. Okay? So today's lesson involved sample space and tree diagrams.